Hi, welcome back. This is the last part of our video lecture in lesson 1 on units, physical quantities, and vector. In this last video, we're going to discuss on the unit vector notation and the multiplication of our vectors. Let us start with the unit vectors. What are unit vectors? A unit vector is a vector that has a magnitude of 1 with no units. Our three most common unit vectors are our vector I, j hat, and k hat. The unit vector I hat points in the positive x direction. Your j hat points in the positive y direction. And lastly, your unit vector k hat points in the positive j direction. Again, the symbol hat, for example, this symbol here, this is read as a hat. So you have your I hat, j hat, and k hat. Any vector can be expressed in terms of its component as, let's say, for example, vector A. Here, you have your ax I hat plus ayj hat plus azk hat. You have here your ax, the magnitude of your vector A along the x component, and then the direction I hat, plus you have the magnitude of A along the y component, and then the direction j hat, plus you have the magnitude of A in the z component, k hat. Looking at your xyz plane, you have here your I hat on the x-axis, your j hat on the positive y-axis, and then your k hat on the positive z-axis. You also have, when we say negative I hat, it goes to your negative x-axis, or negative j hat, it goes downward to your negative y-axis, and then your negative k hat goes inside or into the page, or to the negative z-axis. Okay. Now let us look at your unit vectors in more detail. Suppose we have, say for example, your vector A, and your vector A has 3 units of magnitude along the x-axis. So you have 3 I hat and 4 units of magnitude along the y-axis. If we're going to draw this vector, that means that those 3 units along the x-axis and 4 units along the y-axis. So our vector A goes like this. So this is here our vector A. Now let us find out the magnitude of your vector A. The magnitude of your vector A is just from our, you can find the magnitude of your vector A just from the Pythagorean theorem. That is the sum of the squares, and then we get the square root. So we have 3 squared plus 4 squared, and then we get the square root. So your vector A, or the magnitude of your vector A, is just the square root of 25, or we have 5. Now, you have here the magnitude of your vector A, 5 units. Now, clearly, your vector A is not a unit vector. That's because, again, your unit vector should have only magnitude of 1. But here, your vector A has a magnitude of 5. Now, suppose I want to find this unit vector here of magnitude 1, but points in the same direction as A. So what is this unit vector here? Okay. One way to find it is, or before that, let me call that unit vector as u hat. Again, you read this one as your u hat. Okay. That is referring to this blue line vector here. Now we can find it by having your magnitude on the x be divided by the magnitude of your vector A, okay, plus your AY J hat, and then we divide it by the magnitude of A. So if that is the case, we have here your 3I hat divided by 5 plus you have 4 J hat divided by 5. So let us look at if your 3 over 5 I hat plus 4 over 5 J hat is indeed a unit vector. So let us look at the magnitude of your U hat. So this is just 3 over 5 squared plus 4 over 5 squared, and then we get the square root. So we have here, this is 9 over 25 plus 16 over 25. Okay, so 9 over 25 plus 16 over 25 is just 25 over 25, or you have the square root of 1, which is just 1. So indeed, your 3 over 5 I hat plus 4 over 5 j hat is indeed a unit vector. Okay, so this is an example of a unit vector. You have u hat equals 3 over 5 I hat plus 4 over 5 j hat. In terms of the unit vector notation, which is we're using again your I hat, j hat, and k hat, in adding your vectors using your unit vector notation, say for example in 3 dimensions, okay, if say for example you have your vector A given by this vector here, okay, and you have ax I hat plus ay j hat plus az k hat, and then you have your vector B given by this vector here, you have your bx I hat plus by j hat plus bz k hat, and then we want to find your vector r, the resultant vector r, which is equal to your a plus b. So in adding this vector, what you need to do is just you add the vectors on, or the vectors that are pointing in the same direction. So you're going to add all the x's, all the y's, and then all the z's. So your vector r then is equal to your ax plus bx, and then we carry the direction I hat, or the unit vector I hat, plus ay plus by j hat plus az plus bz k hat. And your ax plus bx is just rx, your ay plus by is just ry, and your az plus bz is just rg. So this is how you're going to add the unit vectors, or the vectors using your unit vector notation. So you just add the vectors that points in the same direction. So in 2 dimensions, you have, like say for example, you have your 2 vectors ax I hat plus ay j hat, and another vector b, you have bx I hat plus by j hat. So adding your a plus b, you have your ax plus bx. So we add everything on the x component. Carry the direction I hat plus your ay plus bz j hat. Okay, the magnitude and direction are still the same as we have discussed before. So your r is just, or the magnitude of your vector r is just rx squared plus ry squared, and then you get the square root to find for the direction theta. That is just your tangent inverse of ry over rx. Let us have an example of your addition of vectors using your unit vector notation. Given the two displacements vector d of 6i hat plus 3j hat minus 1k hat meters, and vector e of 4i hat minus 5j hat plus 8k hat meters, Find the magnitude of the displacement 2D minus E. Again, here we are given with two vectors, vector D and E, and we're asked to find the magnitude of the displacement 2D minus E. Okay, now let's solve this problem. Suppose we call your 2D minus E to be your vector F. Okay, so you have your 2D minus E. So we have 2 times 6 I hat plus 3 j hat minus 1 k hat meters, and then minus your vector E of 4 I hat minus 5 j hat plus 8 k hat meters. Simplifying your problem, you have here 12 I hat plus 6 j hat minus 2 k hat meters, and then you have minus 4 I hat minus 5 j hat plus 8 k hat meters. Okay, combining like terms, we have 12 minus 4. So this is for your I hat. So plus, we have 6 minus negative 5. So you have minus negative 5. This is j hat, and plus minus 2 minus 8. Okay, you have 2 minus 8. This is for your k hat meters. Simplifying, you have 12 minus 4, which is equal to 8 I hat plus 6 minus 5, or you have 11. 6 plus 5, so 11 j hat, and plus minus negative 2 minus 8, so you have negative 10. This is k hat meters, but we're not done yet. So our problem is to find the magnitude of the displacement 2D minus E. So we need to find the magnitude of your F, okay, which is just the sum of the squares and then the square root. So you have 8 squared plus 11 squared minus 10, or plus 10 squared plus negative 10 squared, and then we get the square root. Using our calculators, we find that the magnitude of your vector F is equal to 16.9 meters. So this is the magnitude of the displacement 2D minus E, which we previously called your vector F, and this is equal to 16.9 meters.